Hi all. So if you recall, last week I talked to you about how the unit circle was basically a mnemonic device to help you figure out trig values. Well, I'm going to explain how that works now. So make sure you have your notes out. You're going to be using your unit circle drawing that I'm hoping you all made or printed for almost everything for the remainder of the next 3 chapters. So I really encourage you to just have that out and ready and be able to access it when you're doing your work. So get that out if you haven't already. Get yourself ready for notes, and we're going to get started. So if you recall on your unit circle, and I'm just going to draw a quick circle here, and I'm going to just draw a point here. So I'm going to draw this one here. Now, the reason I'm doing this is has its angle value. You can say theta, right? And that's usually we like to express it in radians because then we can use reference numbers. Now, if you think about the angle here, this angle here is then also t. And it has an ordered pair of x, y. Now, x is this distance here, and y is this distance here. And since it's the unit circle, the radius is always 1. Now what you've seen here is I've drawn in a little right triangle. And if I asked you, oh, what is the sine of t? Well, that's opposite y over hypotenuse 1. So sine is always equal to y, the y value of this point, and cosine, it would be adjacent x over 1, which is just x. So if you know that ordered pair, you now know the cosine value and you know the sine value. So if you look at that drawing that you have from last week, all of those numbers, you now know the sine and cosine value for every single one of those angles. Now, tangent, if you remember, is opposite over hypotenuse, not opposite over hypotenuse, opposite over adjacent, which is just the y value over the x value. This also gives us the kind of cool fact that tangent is also equal to sine over cosine. So the table that we did last week has all your sines and cosines, and you can find tangents by just setting up the fraction y over x. There are actually 3 other trig ratios using all the other combinations. So this one is called secant. So I recommend that you fill that in. This is called secant of the angle. And this would be instead of adjacent over hypotenuse, this is hypotenuse over adjacent. This is the reciprocal of cosine. So that you could just have was 1 over x. Just like you have sine and cosine, you have secant and cosecant. Now these two students mess around a lot, which makes sense because secant is 1 over cosine, cosecant is 1 over sine. So make sure you have those in the correct order. Secant, 1 over cosine, cosecant, 1 over sine. And then, as you can hopefully imagine, you also have a cotangent. So sine, cosine, secant, cosecant, tangent, cotangent, which is the reciprocal of tangent, which is also equal to cosine over sine. And if you want to use your values from the unit circle, it's x over y. So this is basically what you're going to be working on. You're going to say, okay, use your table to find all these exact trig ratios. So that's why it's really helpful to have that out in front of you. So cosine of 5 pi over 6. So the first thing you're going to do is you're going to look at your unit circle, or if you can't find it, you can look it up. or you can even start to memorize it. You will start memorizing it eventually. And you're going to say, all right, 5 pi over 6 is pi over 6, so it's going to be one of these 4 points, because pi over 6 is a reference number, means it's close to but not on the x-axis. And 5 pi over 6 is going to be, in fact, this point right here. This is where it might be helpful to convert into degrees just because you're more used to that. So 5 pi over 6, we can convert into 150 degrees. And this to us makes sense. It's like, okay, it's not quite 180. It's not all the way flat, but we're getting close to there. And this point here, we know that we are looking at only those numbers from the list. So 0, 1/2, root 2 over 2, root 3 over 2, or 1. And this is going to have a negative x value based on its quadrant. And it's going to be negative root 3 over 2 and a positive then 1/2. So this is our ordered pair, which means that cosine of 5 pi over 6, or the cosine of 150 degrees, is negative root 3 over 2. We're just taking that x value because x is equal to cosine. The sine, we can say, oh, well, it's sine of 5 pi over 6, same angle. So that's just our y value here, so positive 1/2. Now, with tangents, we are talking opposite over adjacent, or in this case, sine over cosine. So we're going to do sine of 5 pi over 6 over cosine 5 pi over 6, which in this case is 1/2 over negative root 3 over 2. The divided by 2 simplifies out. So negative 1 over root 3, rationalize the denominator, and we end up with negative root 3 over 3. Now, important here, I do expect exact answers. I'll repeat, I expect exact answers. I'm seeing some students, especially in the written work, just typing it into their calculators. And then they're giving me a decimal, which is not an exact answer. And the point of these exercises is to be able to find the answers precisely without a calculator. That is the point of using the unit circle, is to know these values and to be able to find them out relatively quickly. If you're using a calculator, you're getting an estimate, which is fine, except for some exams, especially in calculus, you're not going to have a calculator, and I will expect you to find exact answers when at all possible. Now, for the last one, secant of 5 pi over 6, this is 1 over cosine of 5 pi over 6. So in this case, 1 over negative root 3 over 2. You could also write this as the reciprocal. So negative 2 over root 3. Once again, rationalize that denominator, and your final answer is negative 2 root 3 over 3. All right. Now, we also can use these facts about the unit circle to find out about points that aren't one of the big memorizable ones. So just like we could find other points on the unit circles besides the 12 that I'm asking you to have written on your big diagram, we can use similar logic for other points. So number 2, there exists a terminal point on the unit circle in quadrant 2 for the angle t radians where x is equal to negative 1/3. All right, find tangent of t. So in this case, I am going to use this drawing I have here. If x is equal to negative 1/3, that would be here, and we're in quadrant 2, so we're going to have the positive y value right here. Now, if I think about t degrees on the unit circle, this is t here. We don't need to know exactly what that is. What we can do instead is, since we want to find tangent of t only, they're not asking us to find t, which we'd need a calculator for. Tangent of t is the y value over the x value. Well, we already know our x value is equal to -1/3, and we're on the unit circle, so solve for y with the same strategy that we saw last week. So in this case, I'll say -1/3 for the x squared plus y squared is equal to 1. So therefore +1/9, because the negatives simplify, plus y squared is equal to 1. Y squared is equal to 8/9. So y, since we're looking at a positive y, it's going to be positive √8/9 when we take the square root of both sides, which is equal to 2√2/3. Therefore, the tangent of t is equal to 2√2/3 all over -1/3. Like so. Since the denominators are the same, we can cancel out with 2√2/-1. So our final answer for the tangent of t is -2√2. So have the picture all filled in, your diagram of the unit circle handy for these. But do be trying to do as much as you can through memory and using reference numbers if at all possible, just to get that practice ingrained so that eventually you won't need that tool right in front of you to solve these problems.